This video is about another measure of precision, which is the percentile. Percentiles divide the distribution into 100 parts. This means that we have P sub 1 until P sub 100. And in order for us to solve a percentile of a certain distribution, we follow also a formula that is very similar to the quartiles and the deciles. So we have a percentile. A certain percentile is equal to the lower boundary plus Kn over 100 minus CFP over F of Pk times I. Remember that Pk is the percentile class or percentile that you are solving. Lower boundary or XLB is the lower boundary of the percentile class. Kn over 100 is the locator of the Pk class. CFP is the cumulative frequency preceding the Pk class. And F of Pk is the frequency of the Pk class, while I is the interval. So as you can see, it's very similar to quartiles and deciles. And for us to concretize this, let us solve an example. So supposing we want to find the P90, P50, and P10 of this distribution, the first thing that we need to do is to first solve for CF less than of the distribution. So starting with the lowest class interval, we have 3, the frequency of the lowest class interval rather, we have 3. We add cumulatively until we reach the highest frequency, highest class interval. So 3 plus 2 is 5, plus 7 is 12, plus 8 is 20, plus 3 is 23, plus 4 is 27, plus 2 is 29, plus 1 is 30. So after that, we can now start looking for the different percentiles. So let's start with P90. And our formula would be the lower boundary plus 90n over 100 minus CFP over F of P90 times I. So solving first for the locator, 90n over 100, we will have 90 times 30 over 100, which is 27. So marking that in our distribution, so here is 27 in the CF less than. I will mark the CFP, which is 23, because that is the one preceding, the cumulative frequency preceding, and the frequency of the P90 class, which is 4. Then I will now substitute. So for the lower boundary, all we need to do is look for 40 and then we subtract 0.5. So we will have here P90. 40 minus 0.5 is 39.5 plus 27 minus 23 over 4 times 5. So if we solve this, of course, we need to solve first the one in the parentheses. 27 minus 23 is 4. 4 divided by 4 is 1. 1 times 5 is 5 plus 39.5. P90 is 44.5. Now you might ask, Miss, 44.5 is not in 40 to 44. The truth is, it is there. This is because the true boundaries of 40 to 44 is from 39.5 to 44.5. That's why 44.5 is still part of 40 to 44. Now let's go to P50. So solving that, we will have lower boundary plus 50n over 100 minus CFP over F of P50 times I. So of course, we need to solve first for the locator. So 50 times 50 times 30. Let me do that again. It's a bit messy. So 50 times 30 divided by 100, which gives you 15. And then we will box that 15 here. So we can find 15 in 20. So this will be our P50 class. I will encircle 12 because it's the cumulative frequency preceding, and 8 because that is the frequency. Of course, you get the lower boundary by subtracting 0.5 from 30. So we will have P50 is equal to 30 minus 0.5 is 29.5 plus the lower bound of the locator, which is 15 minus 12, which is the CFP, times divided by 8 times 5. So if we solve that, we have 15 minus 12, that is 3. 3 divided by 8, that would give you 0.375 times 5, that gives you 1.875 plus 29.5, that would give you P50 as 31.375. Again, 31.375 is still within the range of 30 to 34. Let's now go to P10. P10, lower boundary, plus 10n over 100 minus CFP over f of P10 times I. So lower boundary, that would be, so before that, we have to solve for the locator. So 10n over 100, that is 10 times 30 divided by 100 equal to 3. And if we look at our frequency table, we already have a CF that is exactly 3. That's why we'll just box that part. And this will now be our P10 class. So I will encircle the CFP, but there's none. That's why we will put 0 later there. And the frequency 3. So let us substitute. So P10 is equal to 15 minus 0.5 for the lower boundary. We have 14.5 plus 3 minus 0 because there's no other frequency below 3 or class interval before 3. So 3 minus 0 and then divided by 3 for the frequency times 5. So 3 minus 0 is 3, divided by 3 is 1, 1 times 5 is 5, plus 14.5, P10 is 19.5. Again, you might ask, Miss, that's not part of 15 to 19, sobra siya. But actually, that is still part of the class interval because the true limits of the class interval is 14.5 to 19.5. So I hope that you were able to understand how to solve for the percentile, a certain percentile of a distribution.